So this question here, which focuses on vectors and angles between vectors, is taken from paper 2 of the 2019 higher paper, and it's question 14 in that paper. And what we're going to do is use the information in the question to determine the angle between two vectors u and v. So we've got information here. We're told that the magnitude of u is equal to 4 and the magnitude of v is equal to 5. And we've got u dot bracket u plus v equals 21. And we have to determine the size of the angle between the vectors u and v. Now if I've got two vectors u and v, I know that cos theta, where theta is the angle between them, is the equivalent of u dot v divided by the magnitude of u, magnitude of v. Now this looks pretty straightforward because we're told the magnitude of u and we're told the magnitude of v. Fabulous. We've got the bottom, but we don't have u dot v. However, I can take this relationship here and use that to my advantage to find u dot v. If I use the distributive law and multiply at this bracket here, what I end up getting is that u dot u plus u dot v is equal to 21. Now, this u dot u here, they're the same vector, u and u. So u dot u is the equivalent of the magnitude of u squared. Now, the magnitude of u is 4. So that's the equivalent then of 4 squared, which is 16. So what I can do is take this and actually substitute it back into here. Because then I can say that u dot v plus 16 is 21. So u dot v is equal to 5. Now remember, u dot v is the scalar product of the vectors u and v. It's a scalar. It's going to be a number. It's not a vector or anything along those lines. So we're going to get a scalar answer, which we were expecting, and that scalar answer is 5. So now we've got all three parts here. What we have to do is plug it together and see what we can come up with from that. So if I substitute everything in there, what I'll end up getting is that cos theta is equal to the u dot v, so it's equal to 5, over magnitude of u times magnitude of v, so product of these two, it's 5 over 20. To then do it, I then take theta is equal to cos minus 1 of 5 over 20. I'll simplify that to a quarter. So theta is equal to cos minus 1 of a quarter. That's equal to 75.5 degrees, which continues on. If I was to give it in radians, so if the question asked for it to be in radians, I would be able to say that that's 1.31 radians as well, just in case. Just be aware of that. Know how to convert between degrees and radians. Yeah, make sure you know how to convert between the two of them, just in case the question asks for a specific type. If it doesn't, like it doesn't in this case, either variation is fine. So just be aware of that. But make sure you look at the question. If it wants it in radians, stick to radians. If it wants it in degrees, stick to degrees. So there you go, a nice, quick, short type of question. This one working with angles between vectors. This one here in particular is worth 4. First mark for expanding the brackets and using that. Second mark is for then substituting in this part here to get to this. But after you've calculated that u dot u is equal to 16, then your third mark is for getting to cos theta is equal to 5 over 20. And then your final mark is for getting the solution. So 4 straightforward, fairly quick and easy marks that come later on in the paper. Hopefully something to settle the nerves a wee bit, but hopefully for you can get in the bag using the properties of vectors and be able to help yourself along and finish up confidently.